then busy with mensuration. We're just looking at a circle again. This is the 3 formulas that you need to know of a circle. You can write this now in your workbooks. Circumference, 2 pi r, area, pi r squared, and then volume, pi r squared h. So please write this in your workbook. And then we're going to look at a circle a little bit. Right, there's a nice perfect circle. And let's just look at what we should know about a circle. So this is the diameter. You know that this is the radius. This is not new. You know that these parts. Now, what we should also look is this, which we call a chord. A chord. That is then the chord that you have there. Obviously, this part is the circumference. Circumference. And what we're going to look at now is this length. Part of the circumference, can you see that blue part is what we call the arc. That's the arc length. And this is what we're going to learn now today, how to calculate that arc length there. Then this part is called a sector. It's part of the area. Sector, it's like the piece of pizza or the piece of cake that you are eating. That is the sector that we're going to eat. And we are going to learn now how to calculate arc length and sector area. That's the purpose of our lesson today. That's what we want to do, to find those lengths there. Now, we know that circumference is 2 pi r. And you know that area is pi r squared. This is what we already know. And this is what we're going to use now to calculate that arc length and that area length then there. Okay? And the last thing that you can write down there is now arc length. Yes, just now. Arc length. Okay, there's the previous one. There, the circle. Is that what you want? Okay. So as I say, now we're looking at the arc length and the sector area. That's what we want to calculate now. It's not difficult. It's just 2 little formulas that we need to know, and then from there we can work. Okay, can I go on? Okay, so the arc length, what we do, so you have this part looking like this. And what we want to calculate is that arc length. That's what we're looking at now. That's the arc. Now, this is called the angle theta. It's still the angle. And we work with that. We use that angle to calculate it. So the formula is theta. How many degrees do we have in a revolution? Right around here? 360. 360, that's right. So theta over 360 of the circumference, because the arc length is part of the circumference, so of 2 pi r. And that's your formula there for that arc length. Theta over 360 of 2 pi r. Right, and then the sector area. The sector area, as we said, this is now the piece of cake that you want to eat, or the piece of pizza or whatever. This is the sector area that we're talking about. This is part of what? No, of the area. It's part of the whole pizza. It's part of that there. So this one is theta over 360. So theta is then the angle that we have there of the area, so of pi r squared. That's the 2 formulas that we're going to use. Okay. So your brain likes a block, so put it in a block there so that you can see them. That's what we're going to use. Okay, so in the textbook now, Okay, so in the textbook, this is on page 505. Page 505. So page 505. And you can see, look there on page 505, there they are also explaining all the parts then of the circle that we also looked at. You will see that they also have a minor and a major sector or a segment that you have there. And we're starting then on page 507 with try now 14. So page 507, try now 14. Try now 14, that's where we're going to look. Okay, so I'm going to explain the first few and then we're going to start doing them. So try now 14. Right, so let's look at the first one. Find the length of the arc CPD in each of the following diagrams if the radius is 10. So the radius is constant now here, it's 10 all the time. Right, so what is theta in this case? What is your angle here? Page 507. Yes, very good, it's 90 degrees. So my formula is now theta over 360 of 2 pi r. And if you really want to learn formulas, the best way is to, while we do them, write them down every time before you substitute them, rewrite them, and that's how you're going to learn them and remember them. So in this case, it's then 90 degrees out of the 360. It's always out of 360. And what is the radius? The radius is 10. Okay? We can simplify this now to a quarter, but you can also just multiply it. So we're going to say a quarter, or you can say 90 over 360 times 2 times pi times 10. Just look here, you may use for pi, you may use 3.142. That's what they say on the front page of your paper. Or you can use second function, the pi one is usually there at the bottom of your calculator. Okay, so 90 divided by 360, and then times 2 times shift pi times 10, and what is the answer that you have? 15.7. Okay, now let's just learn two things here also. The one is, you must always first write down the unrounded value. For geometry, we first write down that unrounded value because you're going to use it in part B or C. And then we round off and we indicate the rounded off one like that. And in this case, it's 15.7. Your papers also say 3 significant figures unless otherwise stated. So all the time we're going to round off to 3 significant figures. Or they say 3.142. I think in grade 9 or so they learned you to use 3.14. But now we have to use 3.142. Okay, for that one. Make sure that you know how your calculator works. That's also very important now here. Right, that was now the first one. I'm going to do another one for you and then you can try. Number B, what is theta in this case? So we start with a formula, theta over 360 times 2 pi r. What is theta in this case? Yes, 180, so it makes it very easy. It's a half out of 360 times 2 pi r. So actually, that will cancel out. What? So what is the answer that we get? 31.4159. Yeah. It will give us 31.4159, and we round off to 31.4. 3 significant figures. 3 significant figures. Right, I want you now to try number C and D. Let's try number C and D, using the formula all the time. There's the formula. There's the formula. Theta over 360 times 2 pi r. And in this case, the radius remains 10 all the time. Yes? Do you have a question? Okay, what 20, I'm coming 24.43. Okay, and then we round off to 24.4. Don't be lazy with this, because otherwise you have to redo it again. You must use unrounded information in a B part or so. Okay, number D. Oh, look at number D. There we want the big arc, so we're using 300 degrees over 360 of 2 pi r. And what does that give us? 52.36, and this one will round off to, isn't it? 52.4? Three significant figures, 52.4. And obviously this is actually centimeters, because it's arc length. It's centimeters all the time, centimeters. Right, let's look at number 2. It's a little bit different that they ask it. The minute hand of a clock is 10 centimeters long, so we still have a circle. And then they say the minute hand moves 5. Oh yeah, so it's 10 centimeters, but it moves in 5 minutes. So how far does it move in 5 minutes? So there we have to calculate the 5 minutes, yeah, out of 60, because you'll have to, we need to find that angle. Can you see? That's what we want, that angle. It's then the 5 minutes out of 60 minutes. So it's then 30 out of 360 of 2 pi 10, the radius is still 10, and then what is this one's, 5.2359, which is 5.24. It rounds off to 5.24 centimeters. Okay, so that's now the basic thing. Everything is with this one formula today. So now we go over to try now 15. Copy and complete the following table for the arcs of the circle. So again, I'm going to show you the first one. Try now 15. So we have the sector angle, you have the arc length, but you don't have the radius. Can you see? So it will still be the formula of theta over 360 of 2 pi r. We're still going to use that one. So if I substitute now here, the angle is 120 degrees over 360 of 2 pi r. R is what I need to find, and what I have is the answer. I have the arc length, and the arc length is 25. Can you see? The arc length is 25. So it's now just a little calculation there to find it, and it's all about opposite operations here. So I want R, which means I'm going to multiply by 360, because here you are dividing by 360. Can you see? Here we are multiplying, so now we are dividing by 120 times 2 pi r. So it's about opposite operations to get that length then there out. Okay, let's do that calculation. 250 times 360 divide by 120 times 2 times shift pi is equal to 47. No, so the radius 11.9. Yeah, that's what I get. 11.9. 36. No, it's still 11.9. 3 significant figures will still be 11.9, and it's still centimeters because you want to calculate the radius. You want to calculate the radius. Okay. So we're marking now number B, 1B, and again you have to find the radius. So I'm going to say that 230 over 360 of 2 pi r, that's what we need to find, is equal to 6. They give me that arc length. So opposite operations, this is what we're doing here, 6 times 360, and you divide by 230 times 2 pi. And what is your radius length? 49. Is it rounded now? Right, question 2. In the diagram, O is the center of the circle, the reflex angle 315, and the major arc, major is that long arc, the big arc is the major arc, is 24. Find the radius of the circle. So we're going to do it in exactly the same way, that 315 over 360 of 2 pi r, you still need to find that one, and they tell you that arc length is 24. So opposite operations, Rain, what do you have here? What is your radius? 4.37. It rounds off to 4.37. But it is important, what was the one that you got before you rounded? 365. Okay, but still, we want it because we're going to use it in the next one now. So it's 3.7 when you round off. Now they say at B, the length of the minor arc is R. Now, what we actually need there is that angle, isn't it? And what is the angle 360 minus 315? Jaco, what will be that angle there? 45 degrees. So 45 out of 360 of, what do we need to find? The length of the arc. So times 2 pi. And now I use this radius here of 4.365, the unrounded one. That's what you're going to use, that unrounded radius. Okay, and what? Yeah, so the final answer is 3.43. So this is nice ways how they can also ask it, and not just straightforward finding that arc length or finding eventually the sector area. So number 3, a piece of rope is 90 centimeters long. So that is that DC. It is formed into a sector OC ED of a circle, and the arc subtends an angle of 119. Find the radius. So the same thing here. Write down your formula, theta over 360 of 2 pi r. This is what we're dealing with all the time. So it's 110 over 360 of 2 pi r we need to find, and it is equal to 90. Opposite operations, what is your r then? Okay, so if you press the calculator, we get 46.9. 46.9.
Across Africa, in homes, towns and cities, men, women and children will stop. My heart is pumping just thinking about it, and ready themselves in front of their television sets, with hope in their hearts, and wait for the game to start. There is nothing bigger or better. On these days, we'll cry, scream, hurt, and dream. Hundreds of cities, millions of souls, united by football. It's the world's game.
Here we go! Glorious! Oh, it's out of this world! Stay connected to DSTV to watch the world's best football.
at the arc length, the length of the arc. The arc is part of the circumference, grade 11's, circumference, and the formula was then theta out of 360 of 2 pi r. That gives us the arc length. So you had homework, and that was then try now 16. So we're starting with try now 16 on page 509. Page 509. Right. In the first place, you have that table. Copy and complete the following table for arcs of circles. So this time you had to find the angle, but we are using that same formula. So the first one will then be theta over 360. This is what you want to find, times 2 pi. The radius is 3, and that arc length is 10. The arc length is 10. So it's also opposite operations, as we said in the previous lesson. So I can say that theta is equal to, here I divide by 360, so you're going to times by 360. Here you times, so then we are going to divide. And we also looked at the use of pi on our calculators. It's the answer then of that angle. The difference comes in by using pi or 3.142. Angles, it's a good question. Angles is always to 1 decimal place. Remember with trigonometry, we also had it. Angles to 1 decimal place. It says on the front page that. I think let's agree to all use pi. It's actually easier, and because then we get the same answers. So this one is 191. Okay, so now we do A. And A will then work the same way. Theta is equal to, so your arc length is 40. You times it with 360, and you divide by 2 pi, and this time the radius is 20. So now it is 114.6, or if you have 150 now, it's right, but angles to 1 decimal place. This is with trigonometry and geometry, the two rules that we really have to look at now there. Right, now we come to number 2A. The radius of the sector is 14. For each arc length, calculate the angle. So, but look at the rounding here to the nearest degree. Can you see? So now it is different here. So I'm then going to say, using my same formula, theta is equal to, so this is the formula, let's just get it again, times 2 pi r. So theta is equal to the arc length is 12 times 360, and what was, Pesci, what was your radius? 14. No, the radius is 14 all the time. The radius is 14. Okay, yeah, the answer is 49. You're right. Did you have that correct? Okay, so that's why we do that. Right, number B. Janu, what is your answer for number B? 80. Theta is 80 degrees. That's right. Number C, we're using exactly that same method every time. Ruan, 263. Did you do that exercise? Yeah. So theta is 346 degrees. So it is still using that method every time. It's the arc length times 360 divided by 2 pi the radius. That every time it will be divided by 14 because the radius is 14 all the time, isn't it? Okay, now we're looking at question 3. The diagram shows the minus sector OAB of circle. OA is 10, that's the radius, or OB, sorry, is the radius is 10, and the arc length is 21. Find OAB. So it's the same thing, theta over 360, Ashley, of 2 pi, what is the radius? 10, and what is the arc length? 21. So I'm using that same formula. So then we're going to say theta is 21 times 360 divided by 2 pi r, and then what do you get? OAB, 120.3. This time they didn't say to the nearest degree, so we're back to 1 decimal place. Yes. Yeah, let's just look at that one. Now you have to find the arc length of, no, the length of the chord AB. Now, yeah, let me just draw that picture there. Okay, what is the chord AB? It's a straight line, Jan Ivan, isn't it? So now I'm going back to trigonometry now here to be able to do this one. So this one is 10, meaning this one will also be 10, isn't it? And you found the angle now to be 120.3. So now you have to calculate AB. Okay, Jan Ivan. So what did you use? To get that straight line, the third side, you have to use the cosine rule. Okay, I'm listening to yours. Tell me. Yes, I'll do it here. Okay, so I use the cosine rule here. So I said AB squared. And people, this is what it is. Trigonometry and geometry are often mixed. So it's then 2 times 10 times 10 cosine 120.3 degrees. This is the formula that we will be using. Trigonometry that we've done now. And then remember to write AB. It's not AB squared anymore. And it is then that 17.3 with trigonometry. So all the time we are busy with trigonometry as well. And then the last question, am I too quick, Jan Armand? And then the last question, question 3, the diagram shows the minus sector. So again, we've got that shape with the straight line there. This is the sector, this part, the piece of pizza or cake that you're eating. Find POQ, POQ. So how will we find this angle here? This is POQ. Depending on the information that we have, this time this one is 20 and this one is 10. So actually, if I just look there, it is trigonometry, a triangle that I'm using here. It's not the geometry part at this stage. So obviously this one is also, no, this one is 15 and this one will also be 15. So what do I have? Basically 3 sides. So I want to find that angle, isn't it? So cosine O, for those of you who struggle with trigonometry, this is the angle that you want. So this is the one that you're going to subtract. So it will be 15 squared plus 15 squared minus 20 squared over 2 times 15 times 15. It's the cosine rule with the angle. Second function cosine. What is the angle, Jan Indruk? 83.6 degrees. 83.6 degrees. 4A. Okay, and this is the angle that we are calculating now there. So once we've got this one, we can now, the next question is now to find that arc. So the length of the arc, so now it is theta over 360, which is then 83. This is now B. 83.6 over 360 times 2 pi. And what is the radius in this case? Yeah, not the 20, but the 15. I'll multiply there by 15. And Maxine, what did you get for Anna? 21.9. Good, Anna. 21.9 centimeters. Remember, this is arc length, so this is centimeters. Okay, great.